Another major hazard or concern associated with groundwater is that the fresh water in the ground will become contaminated. And groundwater contamination can be a huge issue because the water in the ground is not very accessible to treat. It can, you have to drill wells into the ground or access it in some way in order to treat it. So how does this contamination happen? Well, pollutants can be introduced into groundwater in many different ways. This could be as simple as something accidentally getting dumped on the ground and then seeping into the ground, or it could be something that we just apply to the ground in a fairly benign fashion. We're not intending to pollute the groundwater, but it happens. So let's look at some examples of this. And one other thing besides this idea of point source and non-point source, sometimes we have lighter or denser contaminants. Sometimes contaminants are lighter than water or denser than water, and that can often influence how we treat the contamination of the groundwater. But in general, groundwater contamination is difficult and expensive to remediate or to get rid of. Typically it's done by pumping contaminated groundwater out of the ground, treating it, and then the water no longer being contaminated. There are other methods, for example, bioremediation, where bacteria is introduced into the ground to consume the contaminant, but that's more rare. So the first thing we mentioned was point source and non-point source pollution. So point source pollution is shown on the right here, and that could be some barrels of pesticides that have accidentally spilled and now they're leaking into the ground. However, pesticides could also contribute to non-point source pollution just by the way they're used. So this farmer is spraying his orchard, he's putting pesticides on the trees so the bugs don't eat his fruit. And in doing so, that farmer, as it rains and is washed off of the trees and getting into the ground, it's also forming a type of pollution which is a non-point source pollution. The point source pollution can obviously be a much higher concentration. This might be a lower concentration, but that pesticide is still getting into the groundwater eventually. Another important consideration is whether or not the contaminant is denser than water. And so in this example here, we have an unsaturated zone at the top here in gray, and then I've colored in the saturated zone or the aquifer below the water table in light blue here. And in this case here, there was a waste unit here. This could just be some sort of landfill that was lined, but there's some break in the liner and it's leaking into the ground. If a contaminant is lighter than water, it will just float right on top of the groundwater. It will be the highest part of the water table here. And this is relatively easy to treat. First of all, it's going to remain in the area where the contaminant leaked. It's just going to be sitting on top of the water table. And secondly, to delineate it and then to pump it out of the ground, you would not need very deep wells. You would just need to go down to the bottom of the dark blue here. However, if a contaminant leaks out that's more dense than water, then it's going to flow right down through the unsaturated zone, past the water table into the aquifer, and it's going to continue flowing down and down into the aquifer until it reaches an impervious layer like this shale here. And at that point, it's going to still move. It's just going to keep flowing downhill and the contaminant could end up being miles and miles away from where the leak in this landfill was. So these things, they would require more deeper wells in order to delineate and treat, and dense contaminants can be a huge issue in this way. And once again, contamination is not always something that's done intentionally to harm the environment, but situations arrive where the groundwater gets contaminated. For example, when salt is spread during the winter on roads in order to de-ice them, that salt eventually gets into the groundwater and can make the groundwater more saline. Or this example here, where we have an island or a coastline where we have fresh groundwater that's sitting above salt water. And the salt water is coming in from the ocean, but the fresh water, due to the pressure gradient, is pushing out in this direction here, and actually a little bit of fresh water is being introduced into the ocean here. But if we put a well in this location here, and we started to pump it, we might kind of pinch out all of the fresh water in this aquifer that's shown in the light blue here, and even get down to this interface where the two are mixing, or even just have salt water coming directly out of this well. So this is another example of groundwater contamination where we're contaminating a freshwater well by too quickly pumping out all of the fresh water and just being left with the salty seawater instead.